So in this example, when the power of tangent is odd, think about this. If I have like tan to the 5, this is going to be tangent to the 4th times tangent. And these can all be converted into a secant, which is nice. And then whatever other secants we have over here, I just peel off one of those to join with my tan so that I have secant tan for my du. So the idea is to pull out a secant tangent for du. And if my du is secant tangent, then my u we know should be secant. So let's split this all up. I'm going to write this as tangent to the 4th times, oh, I need an x, huh? Times secant squared, right? So I just pulled one from each. So I went from 5 to 4 on tangent, and from secant, I went from 3 to 2. And then I take those leftover guys and I say, okay, you'll be over here hanging out with dx. So I have then secant tangent dx. So if we let u equal secant x, then du will equal secant x tan x dx. So if I rewrite this, then what I have is, oh, I have tan to the 4th. What am I going to do with that? Let's handle that in a minute. So leaving this guy kind of floating by itself for a second. My secant is u, and then I have du. So the way that we'll handle tangent to the 4th is the same way that we handled even powers of cosine. So this is tan squared squared. And we know that tangent squared, again, from the derivation of the sum of squares formula, we get secant squared x minus 1. And u is secant. So then this becomes u squared minus 1 squared. Certainly you could do that beforehand. I guess it doesn't really matter too much. Okay. So now we have to expand u squared minus 1 squared and then combine all the u's together and then just integrate. So from here we'll get the integral of u squared minus 1 squared by u squared du, expanding, get u to the 4th minus 2u squared plus 1 by u squared du, distribute u to the 6th minus 2u to the 4th plus u squared du, and then we'll just undo the power rule. And then back step. So u was secant. So I get 1/7 secant to the 7th power minus 2/5 secant to the 5th power plus 1/3 secant cubed. For the next example, we still have that our tangent is odd. So this one is a little bit interesting, but the idea is, again, to peel off. If it's odd, we want to peel off tan squared. So you want to pull out a tan squared. Because tan squared becomes secant squared minus 1, and secant squared is the derivative of tangent. What? Let's work it out. So this is going to become tangent x times tangent squared x dx, and then this becomes secant squared x minus 1. So what I get is tan x times secant squared x minus 1 dx. I'm going to break this into two separate integrals, and you'll see why in a second. So I get tan x secant squared x dx minus the integral of tan x dx. Let's do this one first, and we'll do this one second. So for the first guy, the integral of tan x secant squared x dx, this is pretty straightforward. U is tangent of x, so that du equals secant squared x dx, right? Which was the whole reason for pulling out that tan squared in the first place. So here I'm going to get the integral of u du, so 1/2 u squared plus c, and then I back sub 1/2 tan squared x plus c. Then for the second guy, you may be familiar with this from Cal 1. It ends up being the natural log of secant of x. The way that you can do that is if you have, let's see, just tan x by itself. So we know that tan is sine over cosine. So if I were to let u equal cosine of x, then du is going to equal negative sine x dx. So what I get is negative integral 1 over u du. So this is negative ln of u plus c. So this equals negative ln of cosine of x plus c. And whenever we have a constant in front of a log, we can bring that inside the argument as a power, because logs count exponents. I say that a lot. I don't think I've properly explained it to the Cal 2 crew yet. So this is going to be cosine of x to the negative 1. So 1 over cosine is just secant. So this is ln secant plus c. So putting that all together, our final answer is, I'll just write this as tan cubed x dx. So this is going to equal our first guy in pink, which was 1/2 tan squared x, and then our blue guy, I'm subtracting the blue guy, minus ln of secant and my integration constant.